You're welcome to Structures Pro. In today's class, we are going to be loading this structure. This is a concrete building which we have modeled. We have finished the modeling. This is the 3D view of the concrete building. So today's class will be loading of this structure. We're going to apply all the primary loads, the self-weight, the slab, dead load, the life load on slab, finishes, and the wind load. We're going to be applying Eurocode on this. The loading is going to be in accordance with Eurocode. So stay tuned and enjoy the class. Okay, we click on loading. The first thing we do is select the load cases details. Click on add. From here you select dead load. Then we tag it a name. The first one should be self-weight. I can call it dead load number 1. I'll click on add, close. Okay, then I will select the load case which I've created and open it. For self-weight, the software automatically calculates self-weight of every structure. The modeled members, yes. So the factor we use here is just -1. This minus is because we want the load effect to go downward. Of course, that's the actual thing. If we remove the minus, the load will be going upward, which is wrong. So you make sure this minus is here. It's very important. The software is going to calculate the self-weight of the structure. So putting -1 here instructs the software to multiply whatever is the value it calculated with -1. That changes the direction of the load. It's already in y direction, so instead of going upward, this minus will now direct it downwards, which is the actual thing because our load is acting downward, going down to the foundation. That's just the meaning. So I'll click on add, I'll close. This is it. I select my load which I have created and assign it to view. All the modeled structure, the column and beams are going to take up this self-weight which the software have calculated. Yeah, that's it. That's the application. The second one we will apply now will be the slab load. As you can see, I did not model my slab because I intentionally did that. I prefer applying it as a load because when I want to do my slab reinforcement design in RCDC with this software, I don't really need to model it. What I need is the boundary conditions, the column points and beam points. So when I import it to this software, the software designs my slab. So you must not model it. You can model if you want. Nothing holds you. So now I will do my slab load. I'll do my slab load. Click here again, load cases. Click on add. Still under dead load. Click on slab dead load. I'll give it a name again, dead load number 2. This naming is very important to help us during our load combination. I'll click add. Okay, let me go to my Excel sheet where I did calculation. So you have under dead loads, we have slab dead load, which is my dead load number 2. Unit weight of concrete is 25 kilonewton per meter cube. This is for reinforced concrete. while mass concrete is taken to be 24 kilonewton per meter cube. So you must have been seeing the two, but that's the difference. This one 25 is for reinforced concrete, while 24 is for mass concrete. So the slab thickness I want to try is 150 mm. Yes, that's that. So for me to get the dead load of the slab in meter square, sorry, is by multiplying the thickness in meters with the unit weight of concrete. So when you do that, I've already done that with this Excel sheet. If you double click, you see the cells I've multiplied with. So converting the 150 millimeter to meters, you divide by 1000, then you multiply whatever you have with the unit weight of concrete, and that gives you the weight of slab. Then I will add finishes here. Finishes, of course, there will be maybe tiling, painting, plastering, and a lot of things will be done after casting of the slab. So we can take it as finishes. Then I will assume my finishes to be, let's say, 1 kilonewton per meter square, or we can use 1.2, but in this case let me use 1. 1 is okay for me. Now we'll copy this unit. They have the same unit. Oh, sorry, copy. Yes. So when you add up these two, you get the total load. I will apply on the floor as dead load as this. I'll copy this unit as well. Can give it a color. So this becomes my load I will apply on my roof. Okay, so I'll go back 4.75 as slab dead load. I'll add it. Okay, we'll apply it as area load because the unit is in kilonewton per meter square. I'll apply it as area load. Area load is also can also be applied as a floor load. Yes, floor load. Yeah. Let me we can apply it as an area load if we had modeled the slab, because we need to select the area where we want to apply the load. But since we did not model the slab, we can go with floor load. Yes, even plate load requires a slab. You need to model it so that when you select the plate, you'll be able to apply the load on the plate. But we don't have the plate modeled. We just have beam layout. So for us to apply this load, we use floor load. So for here, you type in the load value, which is 4.75. Now, there's something we need to do. We need to put the dimension. Okay, of course, we know the dimension already. Okay, let me quickly do node to node dimension. From here to here is 3 meters. Yeah. Okay. Then from here to here 12.05. Okay. This one is 10 points. Then the sit out is 2.5. Okay, this will help me in the application of this load. So I've put the load already. So I'll now begin to put the range here. So define Y range is going to be at this point. So minimum of maximum of 3 meters is actually at that point. I need this load. Yeah, that's where I have a flaw. Then for X range, we have a minimum of 0. Yes, that's this point. This is 0 point for X. 0 point for X. Maximum of 12.075. 12.075.075. I'm just showing you how to apply a floor load. Then we go to Z this direction. You have 0, minimum of 0, yes. Then maximum of, you have 10 plus 2.5. Let me call up my calculator. We have 10.375 plus 2.5 is 12.875. 12.875. That's that. Then here I need to put a negative sign to show the direction of the load going downwards. Okay, so I'll click add. Yes, so when I click on it, automatically the load is being added on the floors. Okay, we have assigned to all our panels. But if you look closely, you see that this panel, which is very much bigger than the rest of them, nothing was assigned to it. So when you experience this kind of thing, it means you need to add beam somewhere. So let's quickly add beam. This place is actually big. Like I told you when I was modeling it, I said we have beams that will fail here. But let's just add something at the middle. Yeah. Okay, then I'll go to property, assign beam to it. Assign. That's good. So I also need to assign self weight to it as well. Otherwise, you will receive an error message during analysis. Assign self weight. Assign to selected beam. That's good. So when I click on this, you see everything is alright. This is how to assign floor load. Yes, that's good. Okay, then we move to the next one. The next one is wall load. These are our beams here. They are going to carry partition loads, that's wall, block walls that will now cover up these spaces. They have their own load. So let me create another load there, another primary load for that, dead load as well, then wall load. I'll still call it DL3. Sorry, DL3. I'll add. So let's quickly do the calculation. I've done that already. So I have wall load DL3, block density. We have block density of 2100 kilogram per meter cube, which is 20.7 kilonewton per meter cube. That's been converted. If you look at it here, we've converted that. Yes, so we have a block thickness of 9 inches, which is 0.225. This is actually 225. See, because of the cell setting, if I set the setting, if I set the cell to display the correct thing, let me quickly do that. So three decimal places, exactly 0.225. Then block height is 3 meters. So when you multiply all this, you get the block. So when you multiply 0.225 by 3, you get a value in meter square. Multiply it by this, by 20.7, you get a value in kilonewton per meter. So this is our block load. Then I will also add the finishes for my blocks, which is the same thing with the other one we added before. Finishes is equal to, put 1, the same unit. That's good. Then the total will be 15. This plus that, give you 15 kilonewton per meter. Let me give it color. Yes. So we add this thing as a member load, and member load in kilonewton per meter 15. The minus, like I told you, is to determine the direction of the load. It's going downward. Make sure it's global Y. Global Y is different from local Y. Global is speaking to the direction of the whole structure. Local Y is the Y direction of a particular member. So the local Y of a particular member is actually different from the global Y. The two of them don't go the same direction. So the global Y is what you should always use whenever you're applying your loads. That's good. I'll click on add. Then I will select all the beams, on the first floor. Yes. Then I will assign this block to it. Okay, except this one. This one will not carry block. Yeah. Then I will assign, I have to be careful. Assign to selected beams. That's good. The next one is roof load structure. The next one is roof load. We're going to make an assumption on that. Add roof load. That's dead load number 4. You can assume our roof load to be 3.5 kilonewton per meter square, because the slab load is 3.75. So our roof shouldn't be up to our concrete slab, the weight of concrete slab. So if you assume our roof to be 3.5, where it is reasonable and more critical, no matter the height of the roof and the amount of wood work involved. So I think that one will be safe for us. So I'll add it as a floor load. If you check my Excel sheet, see roof dead load dead load number 4, 3.5 kilonewton square. So it's reasonable if I use it like that. It covers whatever, clears off here. So I'll add this 3.5 minus 3.5. That's good. Then my Y range 0 is this point, so I will not use minimum of 0 here, because if I use it, it's going to apply this roof load on this floor and this floor. So I will just say above the first floor, which is maybe, let me just use 4 meters here, so it will go beyond the first floor. Then the second one is 6 meters. That's this place. This level is where I want this load to be applied to. Then X range is the same thing with the previous one, which is 12.075. The Z range is the same thing, I think is 12.875. 12.875. Then we'll add close. So the same thing is happening here for this roof load. So we can do the same thing that we did, add beam there. Add beam here. Go to property, roof beam, assign to selected. It's okay. Do not forget the self weight, very important. Self weight, assign to selected beam. That's good. Okay, so if you will click on our, see everything is alright now. Then the next one is life load. At this point we consult our code, Euro code. I told you before at the starting point that we are going to, that this design is going to conform to Euro code. So you see this table, imposed loads on floors, balconies and stairs in buildings. Say category A. Okay, let's see what category A is. Okay, category A is areas for domestic and residential activities, rooms in residential buildings and houses, bedrooms and wards in hospitals, bedrooms in hotels and hotels, kitchens and toilets. So this is category A for us. That building is a residential building, it's not a big one, it's not a commercial, it's not an office area, it's not, so it's category A we are going to use. So for category A, this is area load. For category A, life load from 1.5 to 2.0. So you can choose figures between these. You can use 1.5 as life load or use 2.0. So for me, I will choose 2.0 for my floor life load. So I will just let me check what I have here. That's 2.0, 2.0. That's what I have here. It's okay. Then I'll add it immediately. Add load. Don't forget to change this one to life load, because when we go to RCDC is going to make use of this our load, primary load we have created here. So this dead load and live load we have chosen here will make it understand which one is our live load and which one is our dead load. So it's very important. Okay, I'll write a floor live load. I'll call it live load number 1. Okay, then I will add the load 2 is a floor load. The floor load as 2 minus 2 minus 2. So here we'll have 12.075. For this one I will have sorry, this is 3. This one is 12.075. Here is 12.875. Okay, I will add close. That's my live load on the floor. Okay, let's quickly add our wind load. We first of all define the wind definition. Click on add. Come here, select this. Say okay. This can as well be calculated manually. Maybe I will do another video to show manual calculation of wind load. I'm going to do that so that we apply it manually with whichever code you want to use is obtainable. Then you click on this exposure condition, take 0.8. Normally use 0.8. I'll apply this to view. Yes. Now go back again. Click on add and generate. So you select category based on your soil report. Will give you that based on the information you have about whatever project you are doing. So this week you know the category of the area. You have categories, different categories. Select it. The wind speed, meter per second. I'll use 40. Some persons use 35.5. Depending on the wind speed around the area, the structure is to be sited. Then exposure, it can be of A, it can be of B, C, D. So depending. There is a building structure, yes. The length in meters is 6 meters high. Now click OK. The forces has been generated. Now click add. That's good. So I'll come down here to create the wind loads. Then don't forget to choose wind. Call this one wind in positive X. Yes. We have wind in negative X. You have wind in positive Z. We have wind in negative Z. That's good. So for this I will add it. wind load. You must select wind load since I have defined it. But the manual own, you don't need to come here. I will show you when I do the lecture. Okay, so for X, you have for positive X, you leave this factor here to be positive. Then we use these values here to show dimensions. So Y range for X from 0 to 6 meters, so cover all the length from 0 to 6 meters. Good. Then for X range from 0 to 12.075. For Z range, you have from 0 to 12.875. So it's not an open structure because it's a block building. It's going to be closed. It's not an open structure. So I'll click on add. So okay, let's see. That's good. This is how the wind is going to attack the building from this side. Yes, it's not an open structure. If I had checked that box as open structure, you see this wind affecting the internal columns, which is not going to be so. The blocks will not allow wind to pass through and affect the internal columns. Yeah. But when we did the elevated water tank is an example of an open structure. It is open. So the wind that is affecting the first column will definitely affect the second one. So we go ahead to add the other ones. So here we will put negative here to change the direction. Then we'll still repeat our boundary conditions here. 12.075. Click on add. I will click on this and assign that one separately to it. So wind load, okay, that's positive Z. This is still 6. This one is 12.075. One is 12.875. We'll add it. That's good. Then the last but not the least, wind load minus. If you don't remember this minus, the direction will not go the way you want it. 12.075, 12.875. That's good. So let's see. We have wind load in positive X, we have wind load in negative X, we have wind load in positive Z, we have wind load in negative Z. That's that for me. So this one has an issue. This is supposed to be acting on this other face, not that face. So let's see what is the problem. Yeah. Okay, so okay, or this problem should be here. It's not supposed to start from minimum of 0 to 12. Meanwhile, the structure is block structure, so it should be from 12 to 12, 12.875. Yeah, exactly. Okay, that's another thing. Okay, that's another thing. It's not getting to the 2.5 ohm, so let me reduce it. Let me say uh, 10 meters, 5 exactly. So this is it. It's very correct. Let me check the other one for x is correct. One of positive x is correct. Yeah, this one is correct. Okay, we'll end here today. In our next class, we are going to be doing load combination with Eurocode. The one we did for our steel design, we used American code for the load combination. So here we are going to do load combination using Eurocode factors. So I will urge you, if you are yet to subscribe to my channel, I will beg you to hit the subscription button now. Subscribe and stay tuned as I keep unfolding a lot of things in my channel. Thank you and see you next time.